With a lot to cover, let's jump right into OpenEye's 2023.2 Suites and Modules release highlights, including new flows and major enhancements. Making its debut in this release is the 3D QSAR flow package for predicting potency or binding affinity. The prediction process is divided into 4 parts: model building, prediction, validation, and graphical interpretation. The builder flow constructs each model as a consensus of 4 separate models. Using multiple machine learning techniques applied to 3D descriptions of similarity in shape and electrostatics. And a model based on 2D descriptors is also built as a baseline. A global applicability domain model is built based on a molecule's maximum similarity to the training set, and prediction confidence is provided accordingly. The predictor flow allows you to make potency predictions based on a previously built model. Note that the builder's flow output model will be read as the input model in the predictor and validation flows. The validation flow performs validation of a model against an external dataset. Generally, our models outperform traditional 3D QSAR methods such as COMFA and COMSHA, and is comparable to more recently developed methods, even those using quantum mechanics-based descriptors. The interpretation flow is able to provide a visual abstraction of the model, highlighting regions of space where specific functional groups contribute positively or negatively to binding affinity. Also debuting in this release, the protein sequence to AI folded structure prediction flow is a third-party sequence-to-structure protein folding method that uses a large language model to predict protein structure without the use of multiple sequence alignments. You can select the default parameter files from OmegaFold, or upload your own parameter file through the QParameters. Likewise, you can customize all parameters from the original source. The flow outputs the predicted structure, both as a modeling-ready design unit and a PDB file. Note that if you use the parallelization of the flow, you can submit multiple sequences at once that will run isolated instances of OmegaFold on each sequence, and a unique record will be created for each sequence. In addition to our new flow packages, we've made important feature enhancements and performance improvements. Firstly, we've added the option to apply bespoke force field parameters to our Binding Affinity package, which allows you to apply the bespoke torsion angles, bond lengths, angles, and other parameters to the force field. Use the bespoke force field parameters for a specific ligand by uploading the bespoke OFF XML files and running our associate force field OFF XML files to ligand record flow. This integrates the bespoke parameters that you specified in the OFF XML file to the ligand dataset, so that anytime you use the output dataset from the flow, those bespoke parameters will be automatically used in our MD products, such as standard MD, short trajectory MD, and NES. We've also added the option to apply one or more custom force field files in the Smirnov XML format. By using either a bespoke force field to parameterize specific SMRCs for specific ligands, or a custom force field to parameterize specific SMRC patterns of the entire ligand dataset, you can parameterize your ligands to take special cases into account. Additionally, this release features a new version of the classic CHOMP flow that accelerates the fragment database generation significantly with improved scaling for larger input data. In this release, the flow is exponentially faster and cheaper, with a cost reduction of 50% compared to the previous version. Furthermore, the updated BROOD workflow now takes a BROOD database collection input. For existing BROOD database files, you can use the BROOD database file to collection flow to convert them into a BROOD database collection before running the BROOD flow. The updated BROOD workflow now generates bioisosteric analogs by sequentially going through its different stages and parallelizing them when possible for faster execution. As a result, the updated BROOD workflow now expedites the generation of bioisosteric analogs by 40%, requiring no additional cost. Lastly, we've improved the Gigadock Warp AI model with better molecule featurization and a neural net rather than a linear model when docking more than 100 million molecules. The updated flow costs 30 to 40% less than the previous version with improved performance, producing a hit list that even more closely matches the hit list that a full Gigadock flow would produce. For more details on the Orion Suites and Modules 2023.2 release, visit docs.eyesopen.com.